Hello everyone, welcome to another Into Games Discipline Deep Dive. I feel very out of practice because we haven't done one of these in a little while now, but we are back and we're ready to learn. The learning need never really left, to be honest. Today it's a Wednesday, we normally do these on Wednesdays, and today in particular we're doing a discipline deep dive in sort of the programming discipline. So all of our events are split into these major disciplines within the games industry: animation, art, production, operations, and today programming. And today's talk in particular is going to focus on game engines, the features of a games engine. Do they drive your car? How do you go into gear 6? All of these things I'm sure will be brought up because, you know, why wouldn't they? I'm Jonas. I'm the community and events leader Into Games. It's lovely to see some of you in chat. Hello, hello, hello. Lots of familiar names, lots of new ones. If you're not familiar with Into Games and what we do, we are an organisation that is really focusing on the pipeline between education and the games industry, specifically looking to support people from low income or under-resourced backgrounds. You know, people who might not have had access to consoles and technologies and programming and things like that when they were younger, let alone the time to sit and play and make games. So really kind of focusing on how we can help those people still have a career in the games industry, and providing free educational resources like this is kind of really a really big part of our mission, trying to make sure that people can come and learn sort of really in-depth stuff about making games, about the process, from people who do it. And on that note, it's not me who's going to teach you about game engines, as I demonstrated earlier with my car puns. No, no, no. I'm going to be joined by our guest today, Alan Thorne. Hello, Alan. How are you doing?
Hi, good to see everybody. Thank you very much, Jonas, for introducing me. I mean, it's really great to be here. I'm doing very well, thank you. Looking forward to talking about game engines today.
Excellent stuff. So, before we get started, Alan, do you want to give me your slides just at the bottom of our thing here, and then
absolutely.
Then you've got your knowledge bits, the visual bits. Everyone, please give a warm welcome to Alan here. Alan, I imagine you're going to introduce yourself as part of your slides. So
absolutely.
Exactly. So what I'll do is I'll give you. There you go. Those are yours. You jump up there. Right, everyone.
Thank you.
please be very nice to Alan. Please give a digital warm round of applause. And Alan, they're all yours.
Excellent. Thank you very much, Jonas. And good afternoon, good morning, wherever it is you are in the world. Welcome, welcome. My name is Alan Thorne, and I've had the great pleasure of being a games developer for the past 26 years of my life. I'm incredibly thankful to the world of games and to the games industry for transforming my life and for teaching me so many wonderful, wonderful things. In addition to working in the games industry, and actually it's part of working in the games industry, I'm also a course leader on the Indie Games course at the National Film and Television School, where I help people transform their lives too and enter the games industry and make a big impact in the industry. So that's fundamentally who I am, and most of my experience in the games industry was as a games developer, the act of programming and solving technical problems and doing all of the nuts and bolts stuff that turn games into reality. So the subject of my talk today is the features of a game engine. And we have about an hour to do that. That's a lot to squeeze into an hour, but I'm going to try and do it anyway. But before I go ahead and talk about game engines themselves, I want to get into the area of definitions and specifically who is this talk aimed at. So the first thing I want to get into is the definition of what is a game engine. What do I mean by game engine when I use that term? Some of you may be familiar with game engines already, but if you're completely new to the industry, it may be a burning question in your mind. And so let's try to address some of that. Listed here in the slide in front of you, I've given some examples of real-world game engines out there that anybody today can use. In fact, every single one of the game engines that I've listed here is completely free to download and start using immediately. And as a games developer, you wouldn't normally download all of these and use them all at once to make a game. No. You would normally pick one and use that to create a game. So what exactly is a game engine? What do all of these engines here have in common with one another? Fundamentally, a game engine is a computer program. It is a piece of software, just as a word processor or a spreadsheet application allow you to create documents. A game engine is all of the infrastructure that is needed out of the box for you to build a video game. If you didn't have a game engine, then before you could even start thinking about what was going to go into your game, the story, the characters, the players, before you could even start thinking about all of that, you would have to think like a computer scientist and a software engineer to ask yourself the fundamental question of how am I even going to get this game running on a phone or a PC or a computer? So a game engine tries to take out a lot of that technical nuts and bolts stuff so that you can use that program to create a game. And I'm not going to say easily, because there's still plenty of challenges for a games developer, but actually it allows you to speed up the process if you weren't using a game engine. So it's a program that speeds up the process of games development, and they are, in the contemporary industry, an indispensable program for the majority of developers. So in terms of the structure of this talk, now that I've defined what a game engine is, who are the three kinds of people that I have in mind when I'm addressing this information in this talk, and for whom do I think this material is going to be the most useful? Well, the first identity is the aspiring engine developer. They are people perhaps maybe you eventually one day want to work for Unreal, or want to work for Unity, or want to work for Game Maker building a game engine. Typically, you would be an engineer, a software engineer, developing that program, and that program would eventually be used by games developers to build games. So if you aspire to be an engineer for a game engine, then this talk is a great starting point if you don't know anything about game engines. The second identity is the indie developer. There are a minority of indie developers out there who may look at the available game engines and say, no, not for me. I'm going to build my very own dedicated engine. Well, that's a pretty big task. And if you're completely new to indie development, I don't recommend that path. But nonetheless, there are indie developers who do want to build their own engines. And so this talk would also be a great starting point for you. And then there's the third group, and I can't prove it. I don't have any data, but I think probably this is the majority of people. These are people who are going to use a game engine, maybe because you're working at a games company that's already using one, or you're going to be an indie developer and choose an engine for yourself. In this case, you want to learn more about what's going on from the inside of an engine so that you can use it better, so that you can understand it better and be more effective at using that engine because you understand its fundamental anatomy. So those are the three major identities that I'm going to be addressing when I deliver this presentation, and I talk generally about game engines. And I think it covers perhaps the majority of people who are coming into the games industry today. Okay, so let's get into the nuts and bolts of a game engine. I'm going to make an assumption, which is, let's assume that you're starting out and you want to make a game engine. Even if you plan to use an existing one for the purposes of understanding it better in terms of a game engine's anatomy, it's useful to make this assumption. Let's assume together we're going to build our very own engine from the ground up, from the very beginnings to the end. How would we start to approach that task? How do we need to start thinking about a game engine in order to achieve that end? Building our own engine, starting with nothing. Well, step number one is you need to choose your tools. What are you going to use to build a game engine? And I'm making a recommendation here of two particular tools or pieces of equipment that you need. The first one is you need to choose a programming language. And every coder, every programmer needs to choose a selection of languages that they need to be familiar with. And if you're completely new to coding, my recommendation is to choose one language rather than try to develop fluency in loads of them, because by developing skills in one language, you can translate that to many others. Learn one and become good at it. In the world of games development, the majority of engines that you encounter today are developed in a language called C++. It's a pretty old language, a pretty well-established language, and used extensively throughout the games industry. And it is mainly for those reasons that I'm recommending that language. I could have chosen other languages. There are plenty of other languages available. In fact, I believe there are more programming languages in existence than there are natural languages. But nonetheless, despite all the languages you could have chosen, I recommend C++ simply because there's a lot of material out there for learning it. It's well established already in the industry. And if you're looking at other engines to learn from them, to see what they're doing, then it's useful to be able to read and understand C++. Now, in choosing the language is just one step. The next step is you need a tool to write the language in and turn that into a computer program. And the example of a tool that I recommend to start with doing that is Visual Studio. It's free to download the Community Edition by Microsoft. There are alternative programs that you could use too, but certainly two well-established tools here, C++ and Visual Studio, is a great way. C++ is the language itself, and Visual Studio is the tool, the program that you would use to write the instructions, ultimately to assemble a game engine. So those two key tools certainly is your starting point. But what happens once you've made the decision to use those? What's the next thing we have to decide if we're going to be building a game engine? The next step is you have to decide the kind of engine that you want to make. And this might initially seem to be a kind of vague, loose question. What do we mean exactly by that? Well, when we think about engines like Unity, Unreal, GameMaker, the engine examples that I listed back in my first slide, all of those engines are more or less general purpose engines. The aspiration and the aim of those engines is ultimately to be used by the greatest number of games developers possible. And in order to do that, they have to support the greatest number of game types possible. Racing games, shooter games, casual games, RPG games, sports games, a whole variety of genres for a whole variety of platforms: PC, mobile, console. So tons of games for tons of platforms. The widest possible engine you can build tries to help a user build the greatest variety for the greatest number of platforms. Now, that might be a great approach if you want your engine to be massive and used by a load of people. But it might not be the greatest approach if you're building an engine for yourself only, for your team only, and for a particular set of games that you intend to specialize in making. And so some studios, particularly those who are not using the general purpose game engines, they end up developing their own engine, and they look quite different from the general purpose ones. An in-house custom-made engine might be dedicated for a particular kind of game, a particular platform even, maybe only the mobile platform. The advantages to a dedicated engine like that is they're usually simpler to assemble because you haven't got to accommodate so many different eventualities. You can then develop your engine to focus in a very, very optimized, specific way for its single dedicated purpose. So as an engine developer, you need to think about where on this line, where on this spectrum in terms of the breadth of your engine do you want your engine to be? If you go to the Unity, Unreal, general purpose side, the widest possible width an engine can be, then you have a lot of work in front of you. Now, of course, that's no reason not to make an engine just because it's a lot of work. But it's important to recognize a general purpose means you have a ton of work to do. The more niche side, well, maybe your job is a little bit simpler. Not easy, but simpler because you can focus more narrowly on everything you need to build. And it's important to make this decision. How wide will your engine be pretty early in the process? Because it's going to affect how you're going to engineer this engine further along the line. So key question to ask yourself way back at the very start of the process. Okay, so for the rest of this talk, I'm going to assume that we're going to be building a general purpose engine because I think that's going to speak to the greatest number of people approaching engine development. As I start to introduce particular features or particular tools and technologies, keep in mind that it may or may not be relevant to your engine depending on how narrowly you have defined it. Let's take a look. So here we go. To start to build an engine, what's the very first thing I need to start assembling practically? Component number one. It's not particularly glamorous. It's not something that springs to mind for everybody when they think about an engine. But game engines, like all video games, they have to deal with a lot of data, tons and tons of data. In fact, if you think about most video games that you play today, there probably aren't many other applications comparable in the sheer volume of data, perhaps gigabytes worth of data that they have to deal with. And I've listed some of the types of data here, but rather than focus on those words and on those designations, let's just think more broadly about the data that a game and a game engine has to deal with. So the very first type of data that a game engine has to deal with is the input data, the inputs to an engine. And what are they? Well, if we think about a shooter game, a game where you run around and have to shoot enemy characters, we have the characters themselves. They're likely to be 3D models, maybe ogre characters or robots in the case of shooting game. So robot characters. Now, in those cases, they are a humanoid 3D model. Those models will be built vertex by vertex, edge by edge, as a structural model created by artists using content creation software like Blender or Maya. Those are dedicated tools for building 3D assets. And notice I've used the word asset because the name that's given to the data that we plug into an engine is an asset. Some engines call them resources, but I'll use the word asset going forward. So we have a 3D model. Now, if we think about that 3D model, that's composed of vertices, edges, faces, all the intricacies of a character's surface. In addition to that, we think about the surface of that character, its arms, its legs, the clothes it's wearing, maybe the helmet it's wearing. It all has a color, a texture, an appearance. And that's defined by images that are wrapped around the surface of a model to give it the appearance that it's made of something, tangible materials. So in that case, we're dealing now with 3D models and image files, PNGs, JPEG files, TIFF files. And of course, those characters, when they walk around the level, maybe they make sounds and noises. So again, we're dealing with audio. And I just mentioned that the characters walking around the level. So there's animation data, the walk cycle. All of that is asset data that artists and members of the team lovingly create and craft and bring into an engine as an asset. So there's data that we plug into the engine. Then let's think about people who are going to be using our engine, the game developers themselves. They're going to be building and composing levels and worlds inside the game engine as a tool. They're going to take those NPC, those non-player characters, the robots, and maybe duplicate the robot many times throughout the level to create a world filled with dangerous robots. So they're actually using our game engine to build a level, to build a world, to populate it with tons and tons of level design data. So there we have some additional data that is created by the engine itself. Then when a player is actually going to be playing our game built using our engine, the player themselves will also create data. Most games, or many games, allow the player to save their progress and to restore back to an earlier time, to save their progress, come back later, and continue from where they left off. That inevitably means that the engine allows the player in some way to create data. So there's that memory of what the player did during gameplay. So there's an additional set of data that the engine creates. So we have all of this data, and the engine in some way needs a way to systematize and deal with it. We can't just create a folder and throw a load of documents into it, hoping that it will all work out okay. Because by the time we've reached thousands and thousands of files, and indeed games do deal with thousands of files, then we're going to get pretty much into a mess if we don't develop some kind of system for organizing, categorizing, arranging that data. And as a last piece of data that's absolutely critical to think about, certainly for engine development, is what happens if there's an error? What happens if your game crashes? Wouldn't it be useful to have some kind of information that we could use, a record of what the engine was doing at the time your game crashed, so we could figure out what the problem was and fix it more efficiently? And that's the purpose of an error log, a log file. So the engine needs to create some kind of text document while it's running to keep track of what it's doing and to write out human statements so that if an error happens, a human can check that document and hopefully figure out what the error was. So from the very beginning, component number one, we need to develop some kind of engine, some kind of system within the engine that allows us to store data and to store it efficiently, to process and categorize that data so we can organize which items are relevant for this or for that task. And we also need a way to be able to remove data that we no longer need to use. We don't just want to add data endlessly, but if we figure out that something later isn't relevant, we need a means to delete it without affecting all of the other data that we brought in. And lastly, we want to be able to recycle the data that we bring in. For example, take again the example of the robot that we bring into the level. What if we want a level full of many robots? Well, we could bring in that 3D robot and duplicate that file many times. We could do that. But for every robot we're adding to the level, we're creating copies of the robot file. More efficient would be to say, here is our single template robot, and then in our level, here are many duplications, all of which refer back to that single robot. They all those instances, those many instances scattered throughout the level, they take their template, their origin from a single file. And so we build in a referencing system to ensure that data isn't duplicated when it doesn't need to be duplicated. So that fundamentally is the purpose of component number 1, dealing with data. What's component number 2? Component number 2 is about effectively building the visuals of the game, the appearance, the world, and let's see what that involves. If we go back to our robot example, there was a 3D mesh, a mesh constructed by an artist. But when that artist saves the mesh to a file, the file, it just contains numerical data about the points of the model, the vertices, the location, the position of the structural components of that 3D model. If you open that file inside a text editor, you're only going to find tons and tons of numerical data. So a game engine needs to be able to accept that numerical structured data like a 3D model and then convert it into pixels on a screen that represents the model that's defined by the file. So there's a conversion process, taking numerical mesh data and turning it into visual data that we can actually see on screen. The component of an engine that is responsible for that conversion between numerical data to pixels is called a renderer. And the renderer is responsible for making the visuals seen on screen as pixels. And what I've listed here on this slide are a selection of libraries. So these are libraries and components on the internet that you can plug into C++. So you choose your language C++, you choose Visual Studio. Those are the two tools that we identified at the beginning that you're going to be using to build an engine. But once you've identified those two tools, then there are additional libraries out there that have been made by other people for you that you can download and plug into C++ to achieve the purpose of building a renderer, converting data to pixels. And I've listed here 4 different systems that can render data. And the idea is you don't choose them all, you pick and choose. You pick one of them and you use that exclusively. That is normally how engines work. So we have DirectX. That is made by Microsoft and historically has been used to render graphics for Windows platforms. There's OpenGL, which stands for Open Graphics Library, and has been used to effectively achieve the same purpose as DirectX, but it's always tried to be cross-platform, so it supports Windows, Linux, and Mac. We have SDL, the Simple Direct Media Layer, and that has normally been used to create 2D games. And then we also have Vulkan, which is in many ways designed to be a successor to OpenGL. So in terms of building your game, you need to ask yourself key questions. Which platforms do you want to build for? And do you want it to be 3D, 2D? These are all going to impact your decisions about which rendering library you choose to use when building your own engine. And historically, engines have used pretty much all of these different libraries. So depending on which engine you choose, they'll be using one or the other of them. I believe for example, the open source engine Godot, open source meaning you can download and look at how it's engineered, uses Vulkan. So let's take a look at, we've built the render systems. That's responsible for taking 3D models and turning it into pixels on the screen. And I should say the render is responsible for absolutely everything that you can see in a game. So that does include 3D models, but that also includes textures, lights, UI, the user interface, the buttons that you click, the heads-up display, the items that appear on the screen, such as health bars. If it's a pixel on a screen and you can see it, then it's got there. And the way it's got there is because the renderer put it there. So that's what it's responsible for doing. The next thing, of course, is that appearance is one thing, but appearance is not always the entirety of reality. Let's imagine we have an environment with walls, floors, doors, and a ceiling, and then you put the player character in that world. We don't then normally expect that the player can just walk through walls or fall through the floor. We want those objects to be solid things that you can bump into and which block your path. Now, in some games, if you're a ghost, for example, then maybe you don't want that. But for the majority of games, we want our solid objects to behave like truly solid objects. And it's not enough that they just look like they're solid objects. They also have to behave like solid objects. And so component 3 of an engine is about building realism and believability. It's about making your world obey fundamental laws such that the player believes that they're in a world and not just in some free-floating appearance. And so the way that games normally have done this is they have used what is often, and I sometimes think unfortunately named, a physics engine or a physics system. They normally use this term to kind of talk about objects being able to bump into one another, that gravity pulls you down to the ground, that solid objects are indeed solid objects, and there might be other kind of physical laws that games try to emulate. The reason I say it's a slightly unfortunate term is because when we talk about physics, most game engines do not have in mind string theory, quantum mechanics, and this kind of physics. It's often a Newtonian style mechanics. And what usually is sufficient is that you can't walk through walls, that you have water that behaves like water, that you have some simulation of wind, and that you have enough reality here to create the illusion that this world is real. And so long as it achieves that purpose, normally the physics in most games have been sufficient, whether or not the entirety of the system corresponds to our latest models of science. So I'm going to refer to it here as the kind of reality or the realism system, which includes physics. It might include some other aspects of a game engine that are not strictly speaking part of the physics system. So an example of another reality aspect of a game engine would be the artificial intelligence for the non-player characters. And when I refer to AI here, I'm not referring to AI in the most modern sense of ChatGPT, for example, and generative AI. I'm thinking more in the traditional sense that if you have an NPC robot walking around the level, you don't expect it to take an incredibly convoluted route to reach you. If the robot has spotted you and begins chasing you, you do expect the robot to chase after you and to avoid physical obstacles while doing so, as opposed to bumping into everything in the way. There's a navigation or a steering aspect of some kind of intelligence. So another part of building the reality of a game is some form of artificial intelligence. And Unity, Godot, for example, they use a system called nav meshes internally, which allows AI agents, NPCs, to build a map of the floor, the areas they can walk on versus those they cannot. So combined, physics and AI are about building reality. And what I've listed here, again, as with the render systems, are some common libraries out there that you can download and plug into your game to unlock some additional functionality through C++. It's through the language of C++ that you get access to these additional commands that allow you to build reality into your game to ensure that solid objects are exactly that. Now, some of these libraries are completely free. Some involve a cost. And once again, as with the renderers, you wouldn't necessarily download and use all of these in a single engine. You would choose one, and that would plug into your engine. So I've given you some alternatives that you can use. Physics, Bullet, and Havoc pretty much devote themselves to thinking about 3D and physics in this 3D sense, the physics of 3D objects in a 3D world. Box 2D, by contrast, focuses exclusively on the world of 2D. So if you were building a 2D side-scrolling platform game, for example, then you may choose, well, I'm not going to use these three because they focus on more than I need. And instead, I'm just going to choose a 2D physics system. So plenty of choice out there. And not all physics systems are created equal. Not all are suited for the purposes you may have in mind. And so before choosing one of these, it's not simply a case of throwing the dice and seeing where the numbers land. It's actually about researching which one is going to be the best choice for the kind of games you want to make and for the kind of engine that you are building. So what's next in addition to solidity and realism? Well, we then have input. And again, this might seem obvious, but how do we know what the player is doing and what the player wants to do inside a game? Maybe you're building a game for a desktop PC, in which case you need to read instructions from the player through the keyboard and the mouse. Maybe those two input peripherals are completely sufficient for what you need, but maybe you also want to support a gamepad or some other kind of controller. Maybe on a mobile device, you need to detect the tilt, the rotation of the mobile device. Maybe you're going to create a game where actually there are multiple fingers tapping on the screen. It's not just a single mouse cursor clicking at a location, but maybe there are 3 fingers touching the screen and you need to read data from all of them. So another system that an engine must contend with is how can we know what the player is telling us to do? And that's where an input system becomes incredibly important. And so I've listed here 2 alternative libraries. And again, notice they're alternatives as opposed to choosing both, that you can download and plug into your engine to create input functionality and support player input for a range of devices. And when it comes to input, it's very useful to try to abstract your input in an engine as far as you can. So for example, many keyboards have buttons in different places, and depending on which region of the world you are in, your keyboard may even have different keys. And depending on the range of users you want to try to support, you may be using many different input devices. But given the complete variety of devices, physical devices that you might be using, the input provided by those devices may narrow down to only a few simple operations in your game. Perhaps all the input can really do is move the player left or right, and then the other command might be jump. So effectively, there are only 3 actions: move left, move right, or jump. But there are many different keys on that keyboard, many different buttons on those devices. So often a game engine will try to create an input mapping. That is to say, when you press the left button on the mouse, when you press the space bar on the keyboard, and when you press the X button on the gamepad, all of those 3 operations on those different devices, they map to jump, the simple action of jump. So usually between the input and the game mechanics, there is this intermediate layer that an engine must create, which is about how does one map to the other. Great. So that's the input section. Next is audio. Of course, right now the engine we're building can receive input, can draw stuff on the screen, can organize our data, and can create solidity, but there's no sound. So the audio aspect of the engine is responsible for ensuring that sound and music and voice can all appear in the game at the times we need them to. And normally an engine will try to integrate additional features to just simply playing sounds. We might want to add filters and effects to change the pitch and the tone of those sounds so that we can take a single sound and vary it to make it sound different in different situations. A classic example where many engines do this is they may have only 4 or 5 footstep sounds, but then change the pitch and tone of those sounds to make it sound like that there's a variety of footsteps happening at different points and it doesn't get repetitive. So the audio components here allow you to bring in sounds as assets, to choose when to play those sounds. We also have spatiality with sounds. That is, when you hear a sound, there's going to be a difference in the volume depending on whether the sound is near to you, the player character, or further away, way out in the distance. So these audio libraries also allow us to attach positions to sounds so that it can change how they sound to the player depending upon where they're standing. So these audio libraries, again, are components that you can download and plug into your engine, which you access using the language of C++ to access the commands you need to make the engine behave how you want it to in the realm of audio. What's next? Component 6, scripting. Now, what is scripting and what do I mean by that? Well, at some point, when you've built your engine, you've built the renderer, you've built the physics system, you've built the audio system, you've built all this clever stuff, and you are now in a place where you are standing on the shoulders of giants who came before you. You have an engine. But of course, at some point, you need to give that engine to a games developer and say, now make a game with this. The developer, unless you put in scripting, the developer is going to say to you, great, thank you for your engine. I can't actually build a game with this unless I go back to the original code that you've written, figure out how that makes sense to me, and then make changes to that to support all the behaviors that I need. More efficient would be to say, for the engine developer to say, well, here's the engine. I've wrapped that up in a nice package. Here it is for you to use. And if you want to change how the engine behaves so that it works for your game, for its sequel, for its other games, then I've given you this ability to write your own code, and this code can instruct the engine on what it should do. So you give your users the ability to write their own code that can choose the behavior for their game without them ever needing to go back to the original engine that you wrote and changing any of that. You want to keep that as it is and not have them tamper with that. Instead, you want them to have new, fresh code that they can write to build their own games. So that's where scripting comes in. And this system that I've linked to here, ducttape.org, allows you to effectively plug the language of JavaScript. So the JavaScript language, you can plug that into your engine so that the users of your engine can write their own script files using JavaScript, and it can be used to control the engine you've made. So what's the last component? Component number 7. Well, of course, unless you have component number 7, when you give your engine to somebody, if it doesn't have component number 7, then what you're going to be handing to somebody is a big blob of source code and maybe the ability for the developer, the game developer, to use your engine by editing a bunch of text files, which isn't intuitive, which isn't pretty. What we actually want them to have is a nice GUI graphical editor so that with the keyboard and the mouse, they can actually drag and drop and build a world and build elements through a user interface. So they don't need to go to a text file and set the position of every single object. If they want to change the color, they don't need to go into a text file and say, this should be blue instead of red. Instead, it would be great if they could graphically click on a color picker, choose the color they want. If they can grab the robot model and move it to a different area of the level just by dragging and dropping. We want to give them an intuitive interface that they can use to define how our engine should be used to build a game. Unity has this, Unreal has this, Godot has this. Pretty much every engine today have their own intuitive editor tools, and we want ours to have the same. And if you want to be able to build that for your engine, then you need to find a UI library that you can download and plug into your engine to do that. So what I've included here are links to frameworks that allow you to build a UI for your engine. And the UI libraries that I've used, you would choose one and use that. And the libraries that I've chosen to list here are cross-platform, meaning that the idea is that fundamentally you just need to build it once and it can run on Windows, Mac, or Linux. It's not restricted to a particular platform. It's cross-platform, allowing your engine to be used on a variety of computers. So that's the last key component. Now, of course, real-life engines do have more features than the ones that I've listed. Sure, they do. For example, they have particle system editors to create rain, smoke, and other kinds of things, just as an example of something I haven't mentioned here. But these components that I've listed, I identify as being the core, essential components that absolutely every engine needs to have. And it doesn't really matter whether you're using Game Maker or Unity or Unreal, they're all going to have these fundamental components. And with these alone, you can build games. Of course, I'm sure you can think of many more you might like to add to your hypothetical engine. I will leave that as an exercise for you. And this brings me to the close of my talk, where we've seen 7 fundamental components, the core and essence of a game engine. And if anybody has any questions about game engines or any of that stuff, very happy to try to answer them. I'm going to stop sharing my screen to return back to the main chat window. Thank you.
Fantastic stuff. Thank you very much, Alan. Yeah, comprehensive. I love that you presented it in these layers, you know, these components.
Great.
Really a good kind of start to finish journey over there. And comprehensive as well. I think, you know, I've definitely spent a lot of time around engines just in the last 6 months, or sort of watching other people learn these things, and yet still huge amounts of knowledge there that are completely alien to me, and lovely to see them supported as well through those URLs. What I'll do is, for anyone who's like wants those URLs, I will spend some time making sure that I pull those out, or we can get the slides, and we can send them off to everyone so that everyone can have direct access to that information. So yeah, we're going to enter a Q&A period now, everyone. So this means, like, for the next sort of 10 minutes, just up until 2 o'clock, we've got some time where if you've got a question, please put it into the YouTube chat. And we will read them out. It will take some time to kind of go through them. And then, just as also as a side note, if again this is your first time with Into Games, or you've come from us, you've found out about this event maybe through our LinkedIn or a different social media platform, do highly recommend the Discord, which is in the link of our YouTube channel, or you can find the link up on our LinkedIn page if you're watching from LinkedIn, just because that Discord server acts as a really amazing place to just follow up with all these thoughts and questions. If you ask any questions there, you will get answers from hundreds of game developers, people who are learning this stuff in real time, or people who have been using this stuff for years, just like Alan has. So please make use of that space if you would find it useful. Alan, I'm going to start off with sort of a nice simple question.
Sure.
Because you've told us all about these game engines from a very objective point of view, very factual. But Alan, I want to know from your perspective, when you've developed games and you are an indie developer, have you found a favorite in amongst these engines, or do you find that you might, for one project, use one but then use another project for another? Because obviously, you need to know about
them. Absolutely. So there are 2 parts of this, and one, let's start with the objective part, which is, I think, yes, it depends on what you want to build. Someone might say to me, a plane, well, an aeroplane is much more powerful than a car. It can go up and down as well as forwards and back, but you wouldn't use a plane to travel around the corner or a few blocks. It would be incredibly inconvenient to use it for that purpose. So it depends on the kind of game you want to make. Yes, that is, I think, true. I mean, you get many people who debate about which engine is the best, but I think ultimately you be determined by what game you want to make. But of course, having used engines for a long time, I do have my own personal preferences, the engines that I love to use the most. And I think there are 3 that I particularly love. So one is, I've used the Unity engine for a long time, so I have a deep attachment to Unity. I do think that that's a lovely engine. Another engine that I think is great is the Godot engine, Godot. completely free, open source, an amazing engine with a lot of power to it. So as with Unity, it's free to download, but additionally, Godot is open source, so you can also look at how it's made. And another great engine that I really love is Game Maker for 2D games. So classic retro style 2D games. I think Game Maker has a lovely and a beautiful UI. It really is a pleasure to use to build games. So personally, I think they're my 3 favorites, but that isn't to detract from the others, because every engine is amazing. And if you're starting out with using an engine for the very first time, one thing I would like to say, if you're new to games development, is don't try to learn all the engines at once. Pick an engine, become amazing at it, really great at that engine, because a lot of the skills you learn in engine X is translatable to engine Y. The buttons are in different places.
Nice. Thank you very much for that. I've got some great questions actually coming in from the LinkedIn crowd. Hello to the LinkedIn crowd.
Hello, LinkedIn crowd.
See you. Exactly. So the first question I've got for you, I'll bring it up on the screen. So
Sure.
This is Danny W. Hello, Danny, by the way. Says, so I guess really there's a little bit of a question as well about style guides and what does that mean. But the question as written is, what's your favorite style guide for conventions for conversation with C++? I think this is from the point of view of someone going from C# or Python. So sort of, if you're learning C++ from that perspective, is there a style guide that you could use that you recommend specifically for indie game developers? And again, what does that mean as well, just for anyone that's maybe not familiar with that vernacular?
Well, so there are several things this could mean, but most commonly a style guide is what conventions should you adopt? And these are not compulsory conventions that the language requires of you, but what optional voluntary conventions should you apply to how you write that code in order to make it most readable to a games developer? If you were to write your code and for it to be read by someone else, what styles, what conventions might you adopt in just how you go about naming things, in how you go about structuring your code? What would be a good thing to do? Well, I mean, I have to say different studios have different styles. So certainly in having worked for many different studios over the years, you have to be flexible and adapt. But I think that for my own indie games, I adopt a kind of Hungarian notation, I think it's sometimes called, but it's where you prefix your variable names, for example, with the data types that they are. So for example, just to give you one example without going in too much depth, but if I was trying to keep track of the player's score, well, that's a number. That's an integer. The player's score can be 10, it can be 100, it can be 50, but it can't be 50.5, not normally. So here, when I'm storing the player, I might put an I at the front of it to say I score. And what that little I at the front tells me is that the score is keeping track of an integer, so that I don't need to search through my code all the way back up the top to figure out, it's an integer. I can tell just by the name the kind of data it is. So I appreciate that that's not a rigorous, comprehensive style guide for your code, but it's an example of one thing that I use.
I think like really what's valuable there though is to understand like how would you even approach that topic if you didn't know it in the first place, right? And just understanding its implementation. Like if your code's not going to be seen by anyone, then there's something there, isn't there? Which is the style guide is often for the readability of that.
A good way to look at some of the style guides, though, is that there are a number of open source games out there. Just to give you an example, one of them, The Battle for Wesnoth, is a free open source game. It's good to check out some of those open source games, because what you can see there in C++ is a style guide among the team being applied consistently.
Nice. That's really great advice as well. Hadn't occurred to me that go into open source, go see what other people have done, read their code. Right. Excellent stuff. Thanks for answering that. I've got another question here from Wei Chu. Wei Chu over on LinkedIn says, Hi, Alan. Thanks for the talk. I missed the very start of the talk. I'm not sure if this was discussed. I don't think it was, so it's still relevant. Sure. How would you suggest handling the packaging and shipping of a game when it is built, especially for different platforms? Are there any tools or suggestions or just things that you think that should be looked into on that subject?
Yeah. This is a huge subject, and as new platforms are introduced, the method for building for them changes, and the tools that you need to use to do that change too. there is a dream, I think, among many game developers, which phrase is often being used, is develop once, deploy everywhere. The dream is you make your game once and then you can put it out there on as many platforms as possible, almost at the touch of a button. I wish game development worked like that, but unfortunately it doesn't, because depending on whether you're going to mobile or console, you have a range of different considerations to take into account. And some of those might be straightforward and some of those might be complex depending on what you're aiming for. So for the PC platform and for desktop platform, so here I'm including Windows, Mac, Linux, those are certainly the easiest platforms to start building for. And in many of those cases, you have compiler tools that are already open, often open source, freely available, that allow you to build your games to run directly for those platforms. There are additional considerations you might need to take into account about your game, such as the content in your game, because you can't get your game onto an app store unless it's compliant with certain regulations, and those are often set by the app stores. But what if you want to build your game to mobile? Well, in those cases, there is an Android SDK, software development kit, and there is a similar one for iPhone platforms as well. If you want to develop for consoles, that is more of a closed system. And what the first step in that process is, often you need to apply, for example, apply to Nintendo to develop for Switch, for example. And then when you become an approved developer, they'll send you the necessary material so that you can build your game for those platforms.
Nice. Thank you very much for that. Yeah, it's I think it's a sort of a famous horror story is how hard it is sometimes to get one game on a particular platform, not just because of the development sort of cycles, but also just because of the the admin and the pure kind of licensing and all these bits and bobs. But really cool to hear how that kind of relates to the engine side of things.
Yeah.
Just looking at the time, I think we've got time for one more question. I will keep an eye on chat just in case anything else pops up. But
Sure.
the next question I'm going to ask you is from Techno Jester. Techno Jester asks, so they've used quite a specific example here. So they've said, when do you think it's worth using an off-the-shelf solution, for example, using Bullet for handling your engine's physics, versus implementing it yourself or through a team? I suppose really there's a conversation there about, like, if I was learning an engine for the first time, are there certain corners that I should maybe cut early on where someone else has kind of done this already and done this for me, and I should just implement it so I can get on with the learning? Or where is it more valuable to sit and learn that thing yourself?
Yeah. Well, I think that there are two parts to answering this question. I guess the first one is, if I'm going to use a physics library like Bullet, Havoc, whatever, does it do all the things that I need it to do? If the answer to that question, and one of the ways you can determine that is by looking at the list of features that library supports. So, for example, the library might say, we support rigid body collisions, which normally means two solid objects colliding together. It can tell you when two objects collide together. But it might not support fluid dynamics, and normally that means it's not going to give you the ability to simulate water and liquids. Well, if it turns out you want to simulate water and liquids, then obviously you've immediately said, well, I shouldn't use that library. I should make my own one. So I think the first step is, does this library do everything I need it to do? If the answer is yes, then you have an off-the-shelf solution right there. Now, there may still be a second step to that. The second step is, do I want to go through the process of learning this all myself? And there might be a reason why you might do. Maybe you want to become a physics library developer yourself, or you want that to be your specialism, in which case, yeah, it's worth making your own, because there's a ton of stuff you can learn by doing that firsthand. But if the answer to that is no, I just want to get on making my game and I want to use, and this does everything I need, then there really is no justification to write it yourself.
Nice. I think that's a very good, succinct, clean answer, and I think that brings us to time perfectly.
Yes.
Yeah, pretty much 2 p.m. Pretty much 2 p.m.
Great.
So what we're going to do here is, first off, I'm going to give a big thank you to everyone in the audience. Thank you for all your questions. Thank you, Danny. Thank you, Weichu. Thank you, Techno Jester, for your engagement, your questions. Thanks for everyone who's been chatting throughout this entire process. Just thanks for inputting and caring and being here. It's been really great. If you're watching this in the future, because this recording will be available on the Intergames YouTube channel, then please do feel free to let us know what you thought of the talk in the comments. Give us any feedback, and if there's a question that you didn't get answered, again, join the Intergames Discord community and use that massive knowledge base that we have, and we may be able to answer your questions and help you get further in your game development sort of career or aspirations. My next thank you goes to you, Alan. Thank you for joining us here today on this platform. It's been really great to have you. It's been really great to just hear your input, hear your knowledge.
Thank you. Pleasure. And thank you for inviting me. It's been a real pleasure.
No, it's been a great joy. I was just thinking, you do this, you are a course leader. And it's been so lovely to have you sort of bring just a small nugget of that teaching here onto the platform. We've got a little glimpse into the NFTS kind of course experience.
Thank you. Great. And thank you everybody for joining. It's been good to see everybody today.
Yeah, you've all been great. Everything's been great. We are back next week doing a talk on character art, specifically talking about human anatomy, beast anatomy, creature anatomy. So if you're the kind of person that wants to design cool characters or monsters to fight, I have Monster Hunter on the brain, then that could be a perfect talk for you to check out. All of this and more can be found on the Intergames Discord, website, etc. All the resources are in the description and on our sites for you to enjoy. That's all from us today. Thanks for joining, everyone. Look after yourselves. Best of luck with everything, and chat to some of you soon. Yeah, bye-bye for now.
Thank you. Bye.